Good afternoon. I wanted to see you for so long. We did the Osstem meeting last year here because of COVID-19. Not many people participated, but people joined us online. And this year, we looked forward to the full house, but we have many applicants to participate in the meeting, but we have not a full house, but the many people who joined us online. So we have separate the gifts to be given out for participants who are in person here. I'm going to talk about new products, technological innovations, smart car, 3D printers, virtual reality, Internet of Things, and you would know how much development have been made in this area. What about implant technology? What is the level of development? Is implant technology matured enough? So I'm going to talk about this topic. This is a familiar chart. Product life cycle. X-axis is time, introduction, growth, maturity, decline phases. A product go through these phases. Where is implant? I believe it is here. It is entering into maturity phase, and it will soon reach the peak. The maturity phase, as we take written test, it's hard to get 98%. And it is really difficult to get to 100 from 98%. And implants will be divided into really high brand products versus not so high brand products. And this is the cycle. When a paradigm shift occurs, a new cycle will be made. What is paradigm shift? As you may estimate, it is a digital cycle. This is not an option, but a must to adopt. This is an irresistible mainstream that is upon us. What about other things other than digital? I believe there are many research activities are going on, unlike in Osstem, try to find another cycle. And then we are actually failing in many attempts in such efforts. And I'm going to share my thought on this. Today, I'm going to talk about these three things: UV, KS, and One Digital. Last year, I talked about UV and One Digital in the last year's Osstem meeting, and I believe some of you didn't hear that, so I'm going to go over them again. And the new topic is a KS implant. UV implant doesn't exist, and it is not legally allowed, but for communication purpose, I use the term UV. Let me talk about UV. UV technology needs to be understood, especially in Korea. UV is getting a lot of attention. This year, it lost its energy, but let me go over that. UV 3D surface. The machined surface. TIO layers would be formed instantly, and you're looking at the word aged. Hydrocarbon. The organic materials would be attached to the surface. Hydrophobic. The water drops are formed. I'm not saying hydrophobicity is bad. It is relatively not good. So there's a hydrophobic characteristics, and if UV is projected, the hydrocarbon would disappear and OH would be attached on the surface. Because of OH, H2O would be absorbed. So the surface is aged and goes back to fresh surface. On the right, the energy level is high. So the energy is attracting water. On the left, aged surface has low energy. The problem is the high energy is not maintained. So within an hour, 50% recovery is made. So we studied it in a more deeper way. UV treatment doesn't have uniform effects. Depending on how UV treatment is done, the effect would be different. The general UV, not Osstem UV treatment, the effect is 10 to 20%. The high output UV would achieve 30% of effect. The percentages are indicated. The experiment was done on the rabbits. So if we are talking about big animals, the effect would be reduced and the numbers would be different in humans. UV concept, depending on the waveform of light, UVs have different types. So 315 to 400 nanometers, the UVA. Vacuum UV is between 100 to 200. So we are talking about UVC and vacuum UV. UVC, when UV light is irradiated, it works like a catalyst. Photocatalysis would be made. Radicals are generated to remove the organic materials. As you go left, the energy goes higher. If you go toward a vacuum, the tightly bound organic materials would be removed. The problem is vacuum UV is stronger. If you look at devices, there are UVC and vacuum UV devices. The light is irradiated and only the irradiated part would be effective. So UVC is more favorable when the light is not irradiated fully. Osstem uses these two UVs, dual UV. So it is termed as dual UV, combining vacuum and UVC. In terms of device, at the top, it's UVC. I believe some of you saw that. This is the sanitizers you can find in a restaurant. And there is a vacuum UV, a small device. And Osstem uses these two UVs. And the device would get large. And it's too large to be located in a dental clinic. So this is used in a production line. So it can generate a very huge effect. As I said before, right after the treatment, the energy goes up immediately, but over one day, 100% of the effect goes away. So we were struggling a lot at the beginning. UV treatment device. We were wondering whether we should provide them to dental clinics. It's like a production process. There's a safety problem and inconveniences. So we tried to do homework. I did this when I was the head of R&D center. So we had this mission to resolve. And if I elaborate on the process, x-axis is time when you do UV treatment, y-axis is energy. So the surface energy is low when it is hydrophobic. Hydrophilic means when surface energy goes up a little bit, hydrophilicity would go up considerably. So if a UV treatment is done for 10 minutes, it becomes a very hydrophilic. But also integration characteristic is a different story. So for osseointegration, 1 hour of UV treatment should be provided. So if you look at yellow dot, aging occurs. Aging, the word can be involved here. So over a year, 50%. Over an hour, it is reduced to 50%, and over a day, it is reduced to 100%. So we thought about a mission. That is, catch the lightning, catch the UV. That is the name of the project given to our members in the R&D Center. If you look at the lightning, it is about 1 billion volt. So if you can catch the lightning, the energy shortage problems can be resolved to a great degree. But up to now, nobody could capture the lightning. But Osstem caught the lightning. Let me explain how we do that. So let me explain the efforts that we made. First, 1,500 relevant papers were analyzed. That is a large volume of papers. Second, 200 patents were analyzed, and we did 400 in vitro experiments, and on medium-sized animals, more than 400 animals have been studied, and the UV was cut. BA and soy, these two are the results. We didn't talk about it when we launched the BA and the soy. Let me explain why. So let me talk about the production processes. Axis, the processes. So you can see the dot. The energy is created after assay surface treatment, and then cleaning is done in the next step. So it is wet, energy goes up. The problem is the aging, drying. All the implants are dried after surface treatment, so aging would be done. So the surface energy would become hydrophobic. If it is not hydrophobic, drying is not complete. So if you launch a product here, they don't get aged 5 years or 8 years. So if UV treatment is done, the surface energy would go up quite a lot, but it goes away in a year. So with the BA and soy, we could achieve unexpected effect, which is a material effect. Based on large animals, it goes up to 10%, so 30% of increase is achieved. So aging doesn't occur for 5 years. So always fresh is our slogan. Soy, 3 years. MPA, 5 years. And soy will turn into 5 years. At the left, assay treatment, followed by UV treatment, and so over a day, everything goes back to square one. So BA has 30% effect. So based on large animals, when there is a 30% of increase, clinically the increase of the benefit can be felt. Not in all cases, but in considerable number of cases. If the improvement is 20%, the improvement is not felt quite frequently. So we have achieved the clinical differences in terms of the effect. We talked about UV effect for PA or soy, even though we didn't use the term UV, and we used the term K material. We didn't disclose what material that is because of it is secret. So, dual UV treatment is done on SOI and on BA, dual UV. A material is used, that is D-glucose. D-glucose coating was done and the energy was captured. And soy, we use the K material. K material is a hippies. When we do cell experiment on the batch, pH can be controlled. So HAPPIS is a buffer solution that maintains physiological pH. Soy's K material captures the UV effect and also has a material effect, BA. Bioresorbable apatite has the material effect and A material has the UV effect. So basically, UV treatment is done on the left, SAPA and soy. White means after manufacturing. Blue is 1 year after manufacturing. Red, 3 years after manufacturing. And they do not have fluctuations in terms of the effect. Hydrophilicity draws blood, but the blood should be clotted to facilitate bone formation. The fibrin network can be generated by soy. So over 10 minutes, blood clotting can be made on soy. Using the soy technology, we won the Prime Minister's Award in 2020. So we caught the lightning. So it was awarded by the Prime Minister's Prize. So at the time, Samsung received President's Award, and LG, Hyundai Automobile, and Osstem received the Prime Minister's Award. Would you give us a big round of applause? Do you feel the prestige of the award? So we won Prime Minister's Award with a soy. So let me talk about the UV research activities. We started UV research in 2010, and the first outcome of that research is CA, and then followed by BA and soy in 2018. And other companies in Korea began to produce UV products in 2019. And so UV treatment began to be known from 2019. We already had been doing the research UV treatment, but we didn't disclose it as it is a trade secret. SL Active is submerged in cell line, and at the beginning when CA was used, the clinical benefit was pretty good, and so they used SA product and submerged in the solution to turn it into CA, but it doesn't work. SL Active products were made by some company, and the animal experiment and didn't work because they do not understand the key. The solution is not the key when it comes to CA. It was UV treatment. So we started the UV treatment research in 2010, but Straumann began the research 5 years ago. So the problem is SL Active and CA can last 3 years, but the effect, the aging would be done at 20%. But PA soy will be our focal point in the future for prevention of the aging. In Osstem, General Lee Sun-shin, he said, "Don't let others know about my death." So we have a secret project. So we named the project General Sun-shin Lee. So the Lee Sun-shin project, we have many such secretive projects going on. UV treatment was General Lee Sun-shin project, which means a trade secretive project. So through a long project, so we have come up with a very good product. PA began to be sold from 2016, and 4,500 dental clinics use them, and cumulatively 3.2 million have been placed. So it has been verified over the last 7 years. So it is very safe as it is verified. Soy it began to be sold from 2018. Conservatively, we approach it rather conservatively. So 700 dental clinics are using it, and cumulatively 440,000 of them are placed. But clinically, they have been used since 2013. So it has been verified for 9 years. In Chapter 2, first, KS. Clinically, I believe you have experienced the implant fractures. When we hear the fracture story, we feel very sorry and we become speechless. To increase the fracture strength, we are making a lot of efforts. So we thought, what if TS 4.0 diameter implant fracture strength is as good as 5.0 diameter implant fracture strength? We have not reached 5.0 diameter implant fracture level, but we achieved 4.5 level. If you look at the appearance of these two, they look the same, nothing changed. Surgical, when we do surgery, the surgical protocol, surgical instruments are all the same. However, the apex direction is the different. TS on the left and KS is so only those two directions are different. So the fracture strength is increased. In a container like this, because of the lever principle, the right side would be more strong. So TS versus KS, the depth is different. When roots are deeper, the tree is more getting strength from the ground. So because of this root length difference, the effect is different. The screw is 2.0 in TS and it reduced to 1.6 in KS. So the wall thickness is different. If you look at in the middle, TS 4.5, the thickness is the same. Those screws, the screw diameter is reduced. This is FEM analysis. The smaller diameter is 170 megapascal compared to 182 megapascal on the left. So implant abutment are solidly connected and the force on the screw is reduced. Sink down 11 degrees and 15 degrees. If it is hit by hammer, 15 degrees, the button would not go in further. So sink down 11 degrees and 15 degrees. So 15 degrees would sink down less. So screw loosening. 30 Newton centimeter is used to tighten the screw to compare TS and KS. KS, the value is higher at the initial and after test. The slope is important. So 120 Newton is applied, 150 Newton is applied repeatedly. What is important here is that KS is in yellow. The slope is not as sharp as the red one. That's better. And fatigue test is done on the left. TS 4.0, 100%. 4.5 is 4 times stronger, 138%, and KS3 is 440%, equivalent to 4.5 of TS. So in 2015, the products were tested. After that, KS 4.0 is much more improved. 3.0 to 7.0. One abutment can fit on all of them. One thing is different. The mini implant on the left, 3.5 and 3.0 in diameters. The holes are a little bit smaller, so they go up 3.5 millimeters. The change of height is 0.5 millimeters higher on the left. Everything is the same. One lab analog is different. There's a separate mini analog for this. Two-piece abutment needs to be connected with 2 hands. Otherwise, they can fall down. But we are busy. That was inconvenient. So we made the KS to be connected with 1 hand. How did we do that? The holding function indicated in blue, the polished slot, there are 3 wings, so they can be held. Impression coping had this kind of mechanism. Impression coping is one-time use, but it can be used, doctors use it repeatedly, so it breaks. So impression coping is in 2-piece, but they cannot be held together. Screw hole, screw access hole. The smaller the hole, the prosthesis is more aesthetic and better for making occlusal contacts, and this is favorable against the chipping. So KS is 2.2, reduced from 2.4 of TS. So clinical application of KS, it has been available since October 2019. About 45,000 of them have been sold, and we did the clinical follow-up evaluation in 46 clinics and 258 patients. The population is small, but there was only 1 screw loosening at 6 years, 1 digital. As I said before, implanted technology. The paradigm shift can be brought in by digital technology. Where is the digital technology level? I believe it goes into the maturity level. It passed the introduction phase. A lot of changes can occur in the future. How can that be achieved? Osstem's approach is something I want to talk about. Digital. This is the integrated solution for digital dentistry. The blue one is PMS, patient management system. In the server. And patient registration is used for patient series registration, and for CT taking, the CT scanners and digital cameras are all linked to get data. And patient communication software in the all linked in the PMS, CAD/CAM software, 3D printing, billing, and the patient treatment, record control, and insurance claim, cashier. All these functions are linked. So Osstem, as I said before, where is it now? Patient registration. So the 두 번의 하나로 software are used, and the digital dental platform, PMS, one-click software is launched. This is the Digital Dentistry Foundation, electronic charts and insurance claims, and AI functions are included in here for one-stop service. And CT. T2 is used. So 1213 viewers. We have sold about 1,000 CTs, so the quality of the device is already very validated. And we have partnership with 3Shape, strategic partnership to provide intraoral scanners. Model scanner will be launched next year. And patient consultation, you use diary form for consultation with patients, but we made it digitally one code. It is linked with one click. It is launched, but it will be upgraded in August. Implant planner from 3Shape is used. Osstem developed one guide will be launched at the end of this year, and the guide CAD is used in Implant Studio, and it is one guide is to be launched at the end of this year, and one CAD will be launched in early 2023. Guide, printer materials, DLP LCD printers are launched, and DLP Plus is made, scheduled to be launched in August. The precision is increased, and slicing software required some labor work, but it is more automated. The build plate can be attached and removed using magnetic. And materials is important. Next dent material is provided. This is the best around the world up to now. The problem is it's expensive, so we localize it. Surgical guided temporary crown model materials are developed. So surgical guide is launched, temporary crown, and the models will be launched. On the left, milling machine to be used in the chair side, 4-axis. This is for block. You can see the pictures. This can be used. It is wet type sintering, and on the right, this is for discs. 1 mill 5X. Our differentiator of Osstem is that all milling machines are expensive, very expensive, because there's a motor spindle. So when it is moving, there is a bed, solid bed, because high-speed milling is occurring, so the bed should be solid, not to shake the machine. So we made a cast for the bed, and you will think this is too heavy, but heavy base would contribute to higher precision. So based on our measurements, that is the most precise milling machine. Next, the digital solution on the visit, tooth reduction, and intraoral scanning, prosthetic design, and we want to do it all in one day. If you use semi-sintering, it takes 12 hours. It is not possible to do one day treatment, so we want to finish it within 2 hours. So high-speed sintering materials and devices are developed. We almost completed it. So the digital platform is like this. The PMS link. This is one click based on PMS. CAD software will be used for the integration of all these activities. When you do scan, if you do scan or a CT scan or intraoral scan, merging is very important. If you do merging properly, the result is very good. So your effort is required. Your effort is determining the precision. So we want to get rid of that. AI will take care of up to merging. You don't have to get involved. And automatically design will be made, but the dentists need to confirm the design automatically made. As Dr. Park Chang-jo said, depending on the depth, I'm not a clinician, but if you're a beginner, if you use a guided surgery flapless, you need to check how deep the implant is placed. So this is a pattern learning of users, and adaptation is also done using AI, CAM software, slicing. All these need to be understood by dentists, but we want to go to the direction where you don't have to know about them. So you just push the export button, the output can be made. So in order to complete this, all these devices, software, and PMS are required as well. In Korea, I believe we feel the sense of mission to achieve it in Korea. Let's look at the CAD process: merging, scanning, data modification, setting, insertion path, margin setting, and semantic gap needs to be set, milling adjustment, crown arrangement, crown form modification, occlusal contact adjustment, and minimal thickness adjustment. Over time, 3 shape is more advanced. So white means labor work, the blue ones automated, so it takes about 15 minutes. But on the chair side, it can be done in 5 minutes, whereas the top one at the lab, it can be finished in 15 minutes. But Osstem aims to finish it within 30 seconds. Please give me a big round of applause. We haven't achieved the 30-second goal, but almost there. It looks complicated. The yellow one, PMS software, and above that, in one click, CVCT button is there, and if you push it, CT is taken, and if you push scan, the CAD scanning is done, and automatically merging is done. Dentists do not need to be involved, and the data is merged, and they are in standby, and all you need to do is call them in, and the guided surgery can be clicked, and the guided surgery is enabled. If you go down below CAD, I will talk about this later. Automatically, the design is performed. CAM software slicing will be implemented, and export. You click on the export, then the printing will be done. That's what we are going for. Last slide. The dental office is represented in one circle. Everything will be integrated with the PMS, patient registration, image taking. All digital data are acquired, and treatment discussion with the patient, and simulation, prosthetic design, fabrication of prosthetics delivered to patients, and insurance claim, cashier service, and all these will be done in one-stop service. So I talked pretty fast. These include our plans, and we will finish this as soon as possible. Thank you for your attention.